Alright, I don't have my little section thing up here, but this is still, oops, let's try that again. This is section 5.5, and we'll call it part B. Alright, so it's the same stuff. I'm just doing some more examples. So I'm going to go a little quick. So go back on YouTube, rewind it, watch them, and let's see what we get here. So here's your first example. We're going to have this. E to the x squared, now it looks a little weird, equals 200. We got an e this time. It would be nice if we could cancel out that e. What did we talk about when we went over that homework about canceling out an e? What can we put in front of it? Put an ln. Very good. Okay, put a natural log in front of that, put a natural log in front of that. How does that help us? It helps it because the natural log and the e will cancel each other out. We talked about that earlier. All right, so that'll cancel. And then so what am I left with then? I'm just left with x squared equals what? The natural log of 200. Remember, natural log of 200 is just a number, okay? You're using your calculator for this. Now, how do you get x by itself? Square root both sides. Good. So that'll cancel this. We'll get that. And then you just chuck that in your calculator. All right, so we get the square root of natural log of 200. I put two parentheses. You understand why? This first one is for the 200. This second one takes that whole natural log. All right, and then there you go. We'll go 4 places. 2.3018. 2.3018. That's how you do it. Pretty easy, right? Yep, we talked about that when we went over the homework, so now that should kind of make sense to you. Now, they do give you well, yeah, I don't think I'm going to do that next example. I don't think I give one like that on the homework. So I will go to, I don't know if you're following along in the book, I'm going to go to example 4, and it looks like this. It looks like log base a, yep, of x plus 6 minus log base a of x plus 2. That equals log base a of x. And I'm getting off my screen here. Let me scooch it over. Actually, let me just start with a new slate here. Alright, there we go. Again, I'm not really going to ask you what to do just because of the time frame here. So look at this minus right here. You've got a log of this minus a log of this. We went over this rule a little while back, and that means you're going to divide. You're going to put one log out in front, and you're going to make this a division problem. So we're going to put one log out in front, log base a, and we're going to divide. So you've got x plus 6 over x plus 2. Make sure I wrote that. Yep, it is. Okay, and then that equals, we'll just do this, log base a of x. Now here's the new thing. Now watch. This is this makes things really, really easy. I say it like this. The log of this equals the log of that. So if I take the log of this stuff and it equals the log of this stuff, what must be true about these two things that I've circled? They got to be the same exact thing, don't they? Because if I take the log of this number and it equals the log of this number over here, I'm taking the log of the same exact number then, aren't I? If they're equal to each other. So these two must be equal. So guess what happens to that log a? They basically just cancel each other out. I say this. I don't know. I just remember it this way. The log of this equals the log of that, so this equals that. Just came up with that a long time ago. All right, but it just makes sense to me. The log of this equals the log of that, so this equals that. Does that make any sense? I don't know. You don't like that? Usually people say, oh, okay, I get it, but no. All right. All right, I think I explained it okay with the circles and all that kind of thing. So watch, the logs just cancel each other out, and so what do you have? You got x plus 6 over x plus 2, and that equals x. How would you do this? Get rid of the denominator. Multiply both sides by the x plus 2. So I'm going to multiply that by x plus 2. So what do you get? You get x plus 6 equals, distribute, that's x squared plus 2x. Looks like a quadratic, doesn't it? Everybody's favorite. So let's do this. Let's keep x squared over here. Let's make this a 0 over here. So how do I do that? I subtract an x from both sides. So 2x minus x is x, right? And then I get rid of this 6. I subtract a 6 from both sides. So now I have a quadratic. And this does factor real nice, which is kind of cool. It doesn't always factor real nice, but this does. So this is what? X plus 3 and x minus 2, right? Because it multiplies to be negative 6, adds up to be positive 1. Set them both equal to 0. So x would equal negative 3 and x would equal positive 2. But do we use both of those answers? No, we don't, because you can't take the log of a what? Of a negative, okay? So we're going to just get rid of that one. We're going to keep this one, and that would be your answer. Why can you not take a log of a negative? Watch. Watch. Why can you not take a log of a negative? If I just said log right here, we'll make that base 10. So what would this be? This would be 10 to the x equals negative 1. Is there anything that x could equal to make this thing a negative number? No, even if x is a negative number, even if x is negative, all that does is takes the inverse of this, right? There's no number possible that will make this side negative, right? That's why you cannot take the log of a negative number. I don't know if that makes sense to you or not, but at least I can say that I explained it to you. All right, let's do another one. Here's a good one. Watch this. Natural log of e to the natural log of x minus the natural log of x minus 3, and that equals natural log of 2. All right. Well, we got a couple things going on here, don't we? Look at this. What happens with the natural log and the e right here? They cancel each other out, don't they? All right, so basically, I'll tell you what, just for the sake of time, let's just do this. Basically, we're just left with this then, aren't we? Watch this cool thing. I could even make that bigger. Isn't that cool? Let Con try that, but you can't do that. All right, now what do we do here? We got a minus, so what are we going to make that? Go ahead. You can go. Natural log of what? Oh, it's right there. Pick some stuff up. It's in there somewhere. It says part B. So the natural log of x over what? X minus 3 equals natural log of 2. Here's something we just talked about. Log of this equals log of that. So guess what? This equals that, so that cancels out the 2 logs. Is it B? Yep. All right. Everybody see that? We just talked about that just a few seconds ago. And now we kind of did this too. Let's get rid of the x minus 3. We multiply both sides by x minus 3, so that cancels out. Multiply that by x minus 3, and so you get 2x minus 6. Subtract an x from both sides, add a 6 to both sides, and that's your answer. X equals 6. What do you think? These look complicated and they look weird because you're not used to this logarithm, the natural logarithms, and the e's and all these exponents and your variables in the exponent. It looks like it's real difficult, but if you learn some of the basic rules of logarithms, you can really knock these out, and they're really not that difficult. I mean, basically the rules. Once you learn the logarithm rules, solving these things, solving for x, is basically just like Algebra 1 problems, okay? And I'm not just saying that. I really think it is.
If I could ask you to please dismiss the Junior Jefferson Award students that are going on the field trip at this time. Thank you.
Okay, so I will give you a worksheet, and you can work on that. Yep, that's it. It'll say 55B. Well, this is monumental, isn't it? This is your very last real lecture, new stuff for the year. So remember, we're taking a test on Thursday. We'll review tomorrow.
Can we just not take the test?
How about we take the test? You know what I'm going to do too is I'm going to give you a practice test review as well. I'm not going to make you do it tonight. But we'll probably go over some key problems tomorrow on that practice test. That'll be our review, is going over the practice test. So if you want to do it, you can do it. I would suggest trying it because it is a practice test and it will look almost identical to the actual test, okay? So I would really suggest that you trying it, and then we'll go over that thing tomorrow in class. All right, that's it.